So one of the things that I do need to do is sort of just give you a bit of a review from grade 11. So we will spend a little bit of time sort of just refreshing your memory on a few things, although I will be moving at a bit of a accelerated pace. Thank you. Thank you.
That's the worst.
Can I tweet that? Can I tweet that?
Be my guest. In everyday language, so we're talking about velocity. In everyday language, we can use the words speed and velocity interchangeably. However, in physics, we make a distinction between the two. Very simply, the difference is the velocity is speed in a given direction. You guys know that already, right? Velocity is simply speed with the direction. When we say that a car travels at 60 kilometers an hour, we are specifying speed, but if we say a car moves at 60 kilometers an hour to the north, we are specifying its velocity. Speed is a description of how fast, velocity is just how fast and in what direction. You should probably highlight that. Okay? Highlight that little bit right there, right? Velocity is how fast and in what direction. We will see in the next section that there are good reasons for the distinction between speed and velocity. So here's a question for you. The speedometer of a car moving northward reaches 60 kilometers an hour. It passes another car that travels southward at 60. Do both cars have the same speed, Jordan? Why? Please pay attention. I know. Please pay attention. They have the same speed because the speed is both 60 and there's no direction associated with it. However, do they have the same velocity?
No.
No, because they're going in opposite directions. Opposite directions. One would be positive, one would be negative, right? Okay, so what about constant velocity? And now I got a little picture on the left-hand side there that looks important. From the definition of velocity, it follows that to have a constant velocity requires both constant speed and constant direction. Constant speed means that the motion remains at the same speed. Object does not move faster or more slowly. Constant direction means the motion is a straight line. Object's path does not curve at all. Motion at constant velocity is motion in a straight line at constant speed. So if I were foolish enough to drive my little car around and around in circles, would I be traveling at a constant velocity? No, because my direction changes. You weren't listening very carefully, Jordan. I switched it up on you. I know, because you weren't listening. If either the speed or the direction is changing, then the velocity is considered to be changing. Constant speed and constant velocity are not the same. A body may move at constant speed along a curved path, for example, but it does not move with constant velocity because its direction is changing every instant. In a car, there are three controls that are used to change velocity. Gas pedal, increase the speed. Brake, which is used to decrease the speed. And the third one is the steering wheel, because you use it to change the direction. Okay, so there's your little review on velocity. What is acceleration? We can change the state of motion of an object by changing its speed, by changing its direction of motion, or by changing both. Any of these changes is a change in velocity. Sometimes we are interested in how fast the velocity is changing. A driver on a two-lane road who wants to pass another car would like to be able to pass up and pass in the shortest possible time. The rate at which velocity is changing is called the acceleration. The rate at which velocity is changing. And I'm so pleased I did the little teacher cue there and I saw the highlighters go out. Awesome. You guys are trained well. You're 11. Yes, quick. All right, so we're still talking about acceleration here, right? So acceleration is the rate at which the velocity is changing. How fast that velocity is changing. And remember that the formula for it is A equals change in velocity over time interval. So the acceleration formula, whoops, is going to be, oh, I'm going way too fast here. Just go right there. What is that again? A equals delta V over delta T. Very good. Okay. So that's a formula that you're going to need to know, obviously. Oh, yeah. Oh, stop that. Okay, so we're all familiar with acceleration, say, in an automobile. The driver depresses the gas pedal, appropriately called the accelerator. Passengers then experience acceleration or pickup, as it is sometimes called, and they tend to lurch towards the rear of the car. The key idea that defines acceleration is change. Whenever we change our state of motion, we are accelerating. A car can accelerate well, has the ability to change its velocity rapidly. A car that can go from 0 to 60 in 5 seconds has a greater acceleration than another that can go from 0 to 80 in 10 seconds. So having a good acceleration is being quick to change and not necessarily fast, right? You don't have to have a high maximum speed to be a good accelerator. You just have to be able to get to your maximum speed quickly, fast. In physics, the term acceleration applies to decreases as well. We know that we shouldn't use the word deceleration. The brakes of a car can produce large retarding accelerations. That is, they can produce a large decrease per second in the speed. This is often called deceleration or simply negative acceleration. We experience deceleration when the driver of a bus or car slams on the brakes and we tend to lurch forward. Okay? Acceleration applies to changes in direction as well as changes in speed. If you ride around a curve at a constant speed of 50, you feel the effects of acceleration as you tend to lurch toward the outside of the curve. You may round the curve at a constant speed, but your velocity is not constant because your direction is changing every instant. Your state of motion is changing. You are accelerating. Now you can see why it's important to distinguish between speed and velocity, and why acceleration is defined as the rate of change of velocity rather than speed. Acceleration, like velocity, is directional, so it's a, what kind of quantity? Has a direction? Vector. If we change either speed or direction or both, we change velocity and we accelerate. Most of this book, we're going to be concerned only with motion along a straight line, although you guys are going to be getting into two-dimensional motion shortly. When straight line motion is being considered, it's common to use speed and velocity interchangeably. When the direction is not changing, acceleration can be expressed as the rate at which speed changes. But don't worry too much about that. Speed and velocity are measured in units of distance per time. The units of acceleration are more complicated. We know this already. Review. Since acceleration is the change in velocity or speed per time interval, its units are those of speed per time. If we speed up without change in direction from 0 to 10 on a second, our change in speed is 10 kilometers per hour in a time interval of 1 second. Our acceleration along a straight line then would be 10 kilometers per hour per second, which would mean every second your speed would increase by 10 kilometers per hour, right? 10 kilometers per hour per second is one way to talk about it. We also talk about meters per second squared, right? Okay, so here's a couple questions. Oh, and the answers are there. Do you guys have the answers right in front of you too? Yeah. Oh, that's unfortunate. Suppose that a car is moving in a straight line, steadily increases its speed each second, first from 35 to 40, and then from 40 to 45, and then from 45 to 50. So the acceleration would obviously be 5 what? Kilometers per hour per second. 5 kilometers per hour per second. In 5 seconds, the car moving in a straight line increases its speed from 50 to 65, while the truck goes from rest to 15 in a straight line. Which one undergoes greater acceleration? It would both be the same, okay? Both in 5 seconds. This one's going from 50 to 65. That's an increase in 15. This one's going from 0 to 15, also in the same amount of time. The accelerations are exactly the same. So the initial speed does not have anything really to do with the acceleration, right? Got it, Stefan? What? You got it? I can see you're trying to figure stuff out. You sure? Because the car is going from 50 to 65, which is a change of 15 in 5 seconds. So that's an acceleration of 3, right? Same thing with the truck. It's going from 0 to 15, which is a change of 15 in 5 seconds, 3 kilometers per hour per second. They're both the same. Good? That's basically grade 11 stuff in a nutshell, right? In about 15 minutes. Okay? Now, are there any questions that go there? Oh, there's no questions with yours, right? Now, in your handout there's a second sort of handout that's a little bit more mathematical. And normally I would give you time to work on that now and get you guys to do some questions on the back. But in the interest of me being away, which one? Okay, the second one there. I would normally go to the second handout that's attached. There we go. Oh, okay. So I just read the first one, and then there's a second one here that says 3.3 velocity. Okay, so you'll get some time to work on that in the future. Okay, I would normally do that right now, but I want to cover some other stuff.